Okay, for the bell work, for the first 4 questions, you're determining whether the equation represents a linear or nonlinear function. Anytime you have x raised to a power or the absolute value of x, it is a nonlinear function. If it can be written in the form y equals mx plus b, like what we went over last unit, then you know you have a linear relationship. For number 1, we have y equals x cubed plus 5. Since we have x cubed, it is a nonlinear function. For number 2, we have y equals x in parentheses x plus 12. If you distributed, you would get x squared plus 12x. And since your x is not to the power of 1, you know that it is nonlinear. For number 3, y equals 4/3 x plus 7. That is linear because it's written in the form y equals mx plus b. And for number 4, y equals 1 minus x is also linear because it's written in the form y equals mx plus b. To determine if a relationship is a function, you want to look at your inputs. Each input can have one and only one output, so none of your x values can repeat. For 5, if you look at your x values, all of your x values are different, so we know that we have a function. For number 6, if you look at your inputs, we have 2 inputs of 3. One has an output of 7 and one has an output of 9. 3 cannot have 2 outputs, so it's not a function. So, functions can be represented by a table, graph, equation, or words, and you can compare 2 functions represented in different forms. For the first example, we have that a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second. So we know our rate of change or our slope for a lion is 53 feet per second. We are also given a graph, and the graph on the right shows the speed of a zebra. The rate of change or our slope for the zebra is 59, so we know that the zebra is traveling at a rate of 59 feet per second, which means that the zebra is moving at a faster rate. For the next example, a certain car has a gas mileage of 22 miles per gallon. So our car, the slope or your rate of change is 22 miles per gallon. At the table for your sports vehicle, or at the graph at the right for your sports vehicle, if you look at 1, it's traveled 19 miles. So we have 19 miles per gallon. This means that our car has better gas mileage. For the next 2 questions, we're going to be comparing functions represented by a verbal description. A cell phone company offers 2 texting plans to its customers. The monthly cost $Y of plan 1 is $5 plus an additional 10 cents per text message. So if we look just at plan 1, okay, if you look at plan 1, no matter what, per month you're going to pay $5. That's a number that's not changing. So in your equation, it's going to be plus 5. Each text message you send is 10 cents, and we're going to write 10 cents per text message as 0.10 times x. So we have the equation y equals 10 cents x plus 5. If we fill in our table for plan 1, our x values are already given to us. If you plug in 0 for x, we would do 0 times 0.10 plus 5, and you get 0 plus 5, which is 5. For 10 text messages, 10 times 10 cents is 1, 1 plus 5 is 6. For 20 times 10 cents is $2 plus 5 is 7. If you notice, each time we're going up by 1, So for 30 text messages, we would have, it costs $8. For 40, it's $9, and for 50, it is $10. If we went up to 60, for 60, it would cost $11. If we look at the cost for Plan 2, for Plan 2, there is no monthly fee, but each text message costs 20 cents. So we have the equation y equals 20x. If you fill in your table for Plan 2, at 0 text messages, 0 times 0.20 is going to be 0. For 10 text messages, 10 times 0.20 is 2, 20 times 0.20 is 4, and our table's going up by 2, so we have 6, 8, 10, and for 60 it would be $12. If you look, which plan is cheaper for 40 texts? Plan 1 is costing $9 and Plan 2 is $8, so Plan 2 is cheaper. When are the two plans equal? At 50 text messages, they both cost $10. If you send more than 50 text messages, Plan 1 is going to be cheaper. If you send less than 50 text messages, Plan 2 would be cheaper. For our next example, Megan wants to buy a digital camera for photography class. Store 1 offers the camera for $50 down and a payment plan of $20 per month. So Store 1 is $50 down. No matter what, you are paying $50. Each month is $20, which is where we get 20x from. So for Store 1, if we filled in our table for our y values, after 0 months, 0 times 20x, or 20 gives us 0, plus 50 is 50. For 3 months, we're plugging this back into this equation. 3 times 20 is 60, plus 50 is 110. 6 times 20 is 120, plus 50 is 170. When you plug in 9, you get 230, and 12 is 290. For our second plan, Store 2, it offers the camera for a down payment of $80. So no matter what, you're paying $80. And each month is 15, so that number's changing. That's what goes with our X. For Store 2, after 0 months, it would cost $80. After 3 months, 3 times 15 is 45, plus 80 is 125. 6 times 15 is 90, plus 80 is 170. After 9, it would cost $215, and after 12 months, it would cost $260. Which camera is cheaper when the camera is paid off in 12 months? Look at your table for 12 months. Store 2 is $30 cheaper. And after how many months will the cost of the cameras be equal? At your table, both of them at 6 months equal $170. If you paid off your camera in less than 6 months, Store 1 would be cheaper. In more than 6 months, Store 2 would be cheaper.